This video is over lesson 39, using the distributive property to simplify rational expressions, and it's for my Algebra 1 class. So we're looking at the distributive property in rational expressions. So remember, rational expression is an expression with a variable in the denominator. The distributive property is technically defined as A times the quantity B plus C equals AB plus AC. However, in class, we have extended this, and I like to extend this with my students in general, just to give you kind of the structure and the framework of mathematics. And so the math pyramid is something that I like to help visualize this. So when I'm looking at my pyramid here, what I've realized is that anytime you have a stronger operation outside of parentheses and a weaker operation inside, as long as they are closely related, like multiplication and addition, then that stronger operation outside will distribute into your parentheses. So we'll go to each of the things that are on either side of that weaker operation. So in this case, since multiplication and addition are closely related, that's where we get our traditional distributive property from. And so the A that's multiplied with the quantity distributes across that weaker addition, and we get that AB plus AC. Okay, and so just to be clear here, this actually is the distributive property itself. So everything else in this pyramid here are things that are related to it. Similar concepts to it. That is officially the distributive property there. Now, very, very, very closely related. So multiplication and subtraction, since addition and subtraction basically are the same thing mathematically, they just work in opposite directions. That means if addition is closely related to multiplication, then subtraction is closely related as well. So the multiplication will also distribute over subtraction, and so we get an AB minus an AC. Well, using that same kind of thinking, if addition and subtraction are basically the same thing mathematically, they just work in opposite directions, then we could say that multiplication and division are basically the same thing, they just work in opposite directions. So that means that division must be closely related to addition and subtraction, which since it is, if we have a fraction, therefore, remember that the parenthesis or the numerator is basically in invisible parentheses here. So if we actually had numbers, like if this was 4 plus 8 over 6, before we can divide by 6, we'd have to add the 4 and the 8. So there are invisible parentheses around your numerator, which means that the stronger division outside can distribute to each of the things being added in that numerator. And so this would distribute to B divided by A plus C divided by A, or B over A plus C over A. And then likewise, the same thing then would happen with subtraction, since addition and subtraction are so closely related. So B over A minus C over A. Now if we move up the pyramid, exponents and roots are going to be closely related to multiplication and division. So if we have multiplication and division, this exponent, this stronger exponent, will distribute across the weaker multiplication on the inside. And so that power will go to both of these factors that are being multiplied. So this would distribute to be B to the power of A times C to the power of A. And now there's not really a nice way that I can do this necessarily with my red pen. I mean, I guess I could kind of go like that, I suppose. Even with division, so the exponent will distribute across that division in the parentheses. So the stronger exponent, the weaker division inside. So we get B to the power of A over C to the power of A. And then finally, roots will also distribute over multiplication division, since roots are closely related to those. And so what we'll get here is the root will distribute. So this is the A root of BC. So we'll get the A root of B times the A root of C. So keep in mind, if this is a square root, then these are also square roots. However, if this was a cube root, then these would also be cube roots. And that's a skill we'll be using in later lessons, breaking up those radicals and distributing over things that we're multiplying. And then here, same idea then, that the root will distribute over our division. So we get the a root of b over the a root of c. So we have the distributive property, but then we have a bunch of things that are related to it. And so if we take a look then down here, we've got a few examples then. So we've got the stronger multiplication, and on the outside, the weaker addition inside, which means that the 4 will distribute to the things that we are adding. The things that we're adding. So it'll be a 4 that goes to the 2x, and a 4 that goes to the 5. So 4 times 2x is 8x, and 4 times 5 is 20. Okay. Likewise, the stronger multiplication outside, the weaker subtraction inside. So what are we subtracting? Well, the 3x and the 9y. So 7 times 3x would be 21x, minus 7 times 9y would be 63y. So here we have the stronger division outside of the invisible parentheses. And so the divide by 4 will go to each of the things that we are adding. So it's going to be an 8x divided by 4. Well, 8x divided by 4 is really just 2x. And then it'll be a 12 divided by 4, so plus 3. And now that's very important to pay attention to, because you might have been tempted, if I had just given you this problem, you might have been tempted just to reduce the 12 and the 4 and leave the 8x. Or you might have been tempted to reduce the 8x and the 4, but leave the plus 12. But as we can see here, this stronger division has to distribute to each of the things that we're adding. So 2x plus 3 is the correct answer. And then down here, so same idea here, the stronger division will distribute across the weaker subtraction. So it's going to be a 9x squared divided by 6 and an 18 divided by 6. So there's a couple different ways that we can do this. One way would be just to go ahead and divide that. So 9x squared divided by 6 would be, if I reduce a little bit, a 3x squared over 2, because 3 can go into both of those. And then over here, 18 divided by 6 would just be 3. And so that is one possible answer. We're going to do this one a second time, because another thing that we can do here is, instead of actually dividing by 6, what I could do is I could recognize that 3 will go into each of these terms. And so another way to simplify this one would be to allow the invisible parentheses here. And instead of, again, distributing the 6, let's distribute this divide by 3. And so if I do that, I'm going to have a 9x squared divided by 3, which will give me a 3x squared. And I'll have an 18 divided by 3, which will give me a minus 6. And then on bottom, 6 divided by 3 would give me a 2. And so both of these could be two different ways that we could simplify this. They would both be acceptable potentially. Moving on. So now we have the stronger exponent outside of the weaker multiplication. And so I'm going to distribute that exponent there. So it's going to be a 6 cubed and an x cubed. And then 6 cubed is 216. So 216x cubed. I really should be circling my answers along the way here. I've been bad and I haven't been doing that. So I'll backtrack here a little bit. All right. Continue to move forward here. So now we've got the stronger exponent, the weaker division inside. So the x to the 4th and 5 to the 4th. And so 5 to the 4th is 5 times 5 times 5 times 5. Well, if you know 5 times 5 is 25. Another 5 times 5 is another 25. So how much is 5 quarters? Or 25 quarters? Well, 625 cents. So that's one way to do that. Oh, sorry, I almost changed my exponent there. It'd still be a 4th power. All right, coming on over here. So our root will distribute, so we'll have the cube root of 8 times the cube root of x to the 6th. And so what to the third power is 8? 2 to the third power is 8. What to the third power is x to the 6th power? Well, it'd be x squared. Because if you did x squared to the third power, we would multiply the 2 and 3. That would give us the 6. So this becomes a 2x squared. So over here, so square root, this will distribute to make a square root of x to the 8th and a square root of 36. And so square root of 36 is 6. That's nice and easy. So square root's asking what's squared. So remember, when we do a power to a power, we multiply the exponents, just like we talked about there. So what squared, so what exponent times 2 will give you an 8, x to the 4th. All right. And then down here, we've got the stronger exponent outside, the weaker addition. Here's the problem. If we think about our pyramid, addition is closely related to multiplication. Multiplication is closely related to exponents. But exponents and addition are just too far apart. So this means that if we have, I'll try to go with the same letters here. If we have b plus c to the power of a, this does not distribute. Likewise, if we have the a root of b plus c, roots and addition and subtraction are too far apart. They're 2 steps away from each other instead of just a single step. And so they will not distribute. And so as far as we are concerned right now, we'll learn a skill eventually where we'll learn how to deal with this. But for our purposes right now, we can just know that this is not x cubed plus 2 cubed. And until we learn that future skill, we'd have to stop right there and say that's as much as we can do until we learn more. And so likewise, this would not be 9x squared minus 81. We cannot distribute that, and so we'd have to say we're done. Now this one in here is particularly important because you're going to end up with a formula that'll look a lot like that very soon here. So again, we cannot distribute this. So this will not be the square root of x squared, and it will not be the square root of y squared. So it's not going to be just x plus y. It's a bit more complicated than that, unfortunately. And so likewise here, this will not distribute. So if it did distribute, we would have gotten 4x cubed minus 4, oh sorry, minus 8. For some reason I switched to a cube root instead of a square root. Sorry about that, guys. So that would just be stuck right there until we learn more skills. So just keep in mind that when we're doing distribution, they've got to be within 1 step of each other in order to actually distribute. All right, we're going to go to the second page now. And this is where we're going to bring in our rational functions. And so when it comes to the rational functions, there's a couple things that we need to keep in mind. So first thing we need to keep in mind is denominators cannot be 0. Oops, sorry, I had that up too high. There you go. Denominators cannot be 0. So anytime a denominator would be 0, that needs to be a value that we exclude. And that brings in that vocab term that we had on the front, excluded value. So the value of a variable that cannot be substituted into an algebraic expression. In this case, it cannot be substituted in because it can't be 0. You can't have 0 in the denominator. The other thing we need to keep in mind is we're going to start running across more problems with more complicated exponents. As we can see here in these examples, we have some negative exponents coming up. And so we need to remember that the property for negative exponents says for x not equal to 0, x to the negative first power equals 1 over x. Okay. Or for that matter, we can extend that for x not equal to 0, x to the negative n equals 1 over x to the n. And so anything with a negative exponent can also not equal 0, because anything that's being raised to that negative exponent is going to end up in a denominator. So can't have that. So let's look at the first example here. What stands out to me here is I have a denominator a, so I know that a cannot equal 0. There's an excluded value. And then I see in this fraction here, b cannot equal 0, and finally in this one, c cannot equal 0. So in this problem, I see 3 excluded values. 1 for a, 1 for b, 1 for c. All right, with that being said, we're going to go ahead and distribute and simplify. So if I distribute this b squared a that's being multiplied across this weaker addition, it's going to be b squared a times this fraction and b squared a times that fraction. So looking at the numerators first, I'd like to put them in alphabetical order. That just kind of standardizes it. That way we're all kind of writing the same thing. So I see a b squared, I see an a squared, and I see a c. So I'm going to start with my a squared, then my b squared, then my c. In the denominator, I've got an a and a b. So ab, nice and simple. Plus, and now the b squared a will distribute to this one here. So I got a b squared times an ab cubed. So we're going to start with that a, but then my b squared times my b cubed. Remember, anytime we multiply powers, we add their exponents. So I'm going to add 2 and 3 and get 5. And in the denominator, we just have a times c. So a times c. Now that that's done, I'm going to simplify this as much as I can. So what catches my eyes first is that we've got an a and an a there. And so those will both reduce, become 1s. They're gone. And then over here in this fraction, I see I've got an a squared and an a. So divide those both by a. This will become a 1. This will become just a plain old a. And then a b squared and a b. So b divided by b is 1, and b squared divided by b would just be a single b. And so if I were to simplify this, notice that it's 1 times 1 in the denominator here. So my fraction is going to disappear. If these were numbers, whole numbers up top, we'd have a whole number for the answer, but I have no idea what a, b, and c are right now. So, but I'm just going to make it a, b, c. Because ABC over 1 is just ABC. And then over here we've got a b to the 5th plus c. So that'll still be a fraction. B to the 5th over c. Now that we're done, let's take a look and see at what is still excluded. So this no longer being a fraction, we have no problems. There's no denominator, so there's nothing to exclude there. So here, we still have that c cannot equal 0. So that means that this excluded value is still excluded over here. But remember that anything that's excluded at the beginning still has to be excluded at the end. So just because of the way it's written, we're fine with c. C is good to go. But since a and b are no longer excluded over here, we have to explicitly mention them. So our final answer is a, b, c plus b to the 5th over c, where a and b cannot be 0. All right, moving on to the next example here. So looking at excluded values first, I see in this fraction that u cannot equal 0. And then I've got another fraction here where 8 cannot equal 0, which remember, that's always true, so that's not an issue. We don't have to worry about that. And so we really only have one excluded value. U cannot equal 0. And so if we go ahead then and distribute and simplify, remember that anything that's not written as a fraction really is itself over 1. So essentially anything not written in a fraction is just a numerator. It's just a numerator with an invisible 1 for denominator. So that means W will be multiplied by this, and it'll be all over U when we do our first distribution here. So 5, we always put our numbers first, and then if I put this in alphabetical order, I'm going to put my U to the 4th, and then followed by my W, followed by my U. So 5, U to the 4th, W, U. All over U. Now minus, and so distributing to the second fraction, so U times W, UW in alphabetical order, and then the bottom we'll have 8U because we always put the number first. So some quick reducing here. If I have 4 U's and I reduce it by 1, the 1 will go away, but I'll still have 3 left up top. So we can tell that that's no longer going to be a fraction. And then over here, my U and my U will cancel and both become 1s. And so I'm going to have 5 U cubed W Y, and then minus W over 8. Because 1 times W is W, 8 times 1 is 8. So if we look at the excluded values here, 8 cannot equal 0, but that's always true, so that we don't have to worry about that. That's not a big deal. But is there anything in this that suggests that U can't be 0? Well, there isn't. U is no longer part of a denominator. And so again, if this excluded value is not still a part of the answer, we have to explicitly state it. It has to become part of the answer then. Okay, another way of putting it, if it's no longer implied in the answer, it must be explicitly stated. So up here, the C not equal to 0 is still implied, but A not equal to 0 and B not equal to 0 are no longer implied over here, so they have to be stated. All right, looking at our next one. So there's quite a bit to go through here. So as I look through this, because K is in the denominator here, K cannot equal 0. Also, because K is in a negative exponent, K cannot equal 0. Over here, M cannot equal 0 because it's the denominator. That would make the denominator 0. And then finally, there's a third one that's up in the numerator because we have negative exponents here and here. E cannot equal 0. Excuse me. So in this problem, we actually have 3 excluded values again. Now, it would be my recommendation for this problem to start with dealing with those negative exponents. Now, there's a bunch of different ways we could do this. We could distribute first, but in general, just dealing with negative exponents is not a nice thing. I would just get rid of them first. That would be what I would do. So remember, negative exponents give us reciprocals. That means anything that's in a numerator will just move to a denominator and become a positive exponent. And anything that's in a denominator will move to the numerator and become a positive exponent. So basically, it'll cross that fraction bar, whatever direction it needs to go, and the negative will turn to a positive exponent. So here, 3 is going to be the only thing left up top, but then the e to the negative second will become an e to the positive second, and then since k is just k, it's still there. And then we're multiplying this by, well, these both have negative exponents, so they're both going to move. So this will be a k cubed over an e to the 5th. And then finally, plus 5km. No negative exponents there, so that guy's all good to go. And now we can go ahead and distribute this fraction into the other two. And so my first distribution, 3 times k cubed, will be 3k cubed. All over now e to the second times e to the 5th will make e to the, well, 2 plus 5 is 7th. And then we still have the k. And then over here, I'm going to distribute this then into the other fraction there. And so when I distribute into the other fraction, we're going to have 3 times 5, and so 3 times 5 is 15. But then we'll still have the k. And in the denominator, we've got e squared k times m. So alphabetical order, e squared k plus m, or times m, excuse me. And so we reduce, so I got a k cubed and a k here. So divide those both by a single k, that'll be a 1. That'll be a k squared. K and k are the same, so they'll both reduce to 1s. And that's all I can do as far as reducing goes. So finish this up, clean it up, and we have 3k squared over e to the 7th plus 15 times 1 is 15. And then e squared times 1 times m is e squared m. So if we take a look at our excluded values here, we still have e not able to be 0, but we also have m not able to be 0. Because if either one of these was 0, the whole denominator would be 0. So e and m cannot be 0, e cannot be 0, which means that we still have the e cannot be 0 and the m cannot be 0. But is there anything in here that implies that k cannot equal 0? And since the answer there is no, it must be part of our answer. And then finally, the last example here. So for our last example, we have just a single negative exponent there. So again, that would be the first thing that I would go ahead and start with, is that negative exponent. And so we have RBN cubed times RBG over n squared minus, and again, remember that anything that's not written as a fraction really is a fraction with an invisible 1 for the denominator. So that means that the 7 and the g will stay as the numerator, but the b to the 4th will move to that down with that 1, and 1 times b to the 4th is just b to the 4th. And finally, plus 19 over n. Oh, sorry, ladies and gentlemen, I'm remiss. I forgot to look at my excluded values here. So n cannot equal 0 here, and here, and here. So 3 different reasons why n cannot equal 0. And then finally, I have a negative exponent here for b, so b cannot equal 0. So this time, we just have the 2 excluded values. All right, so back to simplifying this. Now it's time to go ahead and to distribute. So if we go ahead and distribute this, so we're going to have RB, and this is where I'm going to go ahead and put these in order. So I'm going to start with my b's. So b times b will be a b squared. Next is just a single g. Then we have r times r, so r squared. In the denominators, I have n cubed times n squared, so that'll be n to the 5th. 3 plus 2 is 5, excuse me. And then minus rb times 7g, so 7 will go first, and then bgr. In the denominators, we have b to the 4th times n to the 3rd. And then finally, plus that times our last fraction. So I'm going to have 19 br, and then n cubed times n will be n to the 4th. Not a lot of reducing I can do here. So we've got n here, but no n's up top, n here, but no n's up top, n here, but no n's up top. So none of those n's are going to reduce. The only place that I can reduce would be here. So that would just become a 1. This would become a b cubed. And so my final answer then is going to be b squared g r squared all over n to the 5th minus 7gr over n to the 3rd plus 19br over n to the fourth. Oh, sorry, I missed a b cubed there. I knew something was fun. But yeah, b cubed n cubed there. So if we look at our excluded values here, I've got several reasons why n cannot equal 0. And then over here, I've got that b cannot equal 0. And so both of our excluded values that were implied at the beginning are still implied at the end. So it turns out this time, all the excluded values are still implied. So there's nothing extra that I have to write on this one. And that, ladies and gentlemen, is the end of our lesson.